x-intercepts. So we've got these x-intercepts of 4 and -2, and being symmetrical, the turning point will be halfway between, so that'll be at 1, 3, 3. So it's down here somewhere. So it's at x equal 1, and the y value, well, we'd have to put x equal to 1 back up into here to find out. So y equals, into there or there, it doesn't matter, -3 multiplied by 3, I think it's -9. 1, -2, yeah, -9. So we get the turning point that way. I'm going through pretty quickly, but so stop me if you need to. Right? Next one. Say if I have, again, right-hand column on your sheet there on the right-hand side, I'm sketching a graph of x minus 2 squared minus 5, which is the same as that. Same expression, except I'm doing that one. So what can we immediately write down if we've got that format?
You've got the y-intercept?
No.
Oh, turning point, yeah.
You get the turning point.
You smarty.
At 2, -5. Get the signs right. Opposite. And now that's the only way we can get directly from there. We can get the y, well, it doesn't matter about the other two. Y-intercept, we just put x equal to 0. Now, we've got it over there somewhere, but if we've just got this line here, if x is 0, I get -2 squared minus 5, -1, 4 minus 1. So that's the y-intercept, -1, which is the same as that bit there. Or there. And the x-intercepts, that's solving that, isn't it? Y equals 0. The x-intercept, y is 0. And so if y is 0, we've got that, which is that. So it's x equals 2 plus root 5 and 2 minus root 5. They're the two x-intercepts. Now, if you're going to put them on a graph, you probably want to put them as a decimal because it's pretty hard to know where. Now, the square root of 5 is about 2 point, I don't know, square root of 5, 2.2, something like that. So it's 2.2. So that's 4.2. And this one here is about -0.2, roughly. I'm not too sure about the 0.2. -0.2. Okay. Now, so sometimes you're just looking at the equation side of it, sometimes you're looking at the graph. And sometimes you might start here, other times you might start up here. This depends, okay? If you start with this equation here, y equals x squared minus 4x minus 1, the question might simply be, find the turning point. Find the turning point. And how would you do that? How would you find the turning point for that, if that was the question? What would you do? What would you write down? You can, okay. It becomes a bit messy here because of these square roots. Get into how do you change it into turning point form? Complete the square. So you start off, you do that, and you say, where can I write this one? Down here somewhere. X squared minus 4x, half the coefficient of x squared. So add that in. Minus, now that's 2 squared, minus 2 squared, minus 1. And that would equal, in here, x minus 2 squared, 4 and 2 squared, minus 5.
Oh,
So completing the square. Now, any questions there so far? I'll come. Yeah, I'll come.
yeah, it's
4F, yeah, we've got 4F, yeah. Now, so I've got this. Y equals 3x squared plus, I'll make it harder easy, 9x squared plus 1. Oh, wait a minute. Plus 1 minus 1. And I'll find the turning point. Find the turning point of this one. Now, this one's a bit harder. I complete the square again. So what's the first step if I want to complete the square? In this one, this is a bit harder. Take out the 3.
Oh.
Now, it doesn't matter about that. So it's 3 bracket x squared plus 3x. That's nice. Plus 1/3. Okay? 3 times a third, 1. Now, the 3 stays there. And it's x squared plus 3x plus half the coefficient of x squared.
Wait, why isn't the 9x squared anymore?
I'm sorry, that shouldn't be there.
Okay, good. Good.
Yeah.
Should put that there.
Yeah, I'm just
Minus 9 on 4 plus a third. Now the fractions are becoming a bit messy at the end there, but that's okay, that'll work out. So it's 3 bracket x plus 3 on 2 squared. Those first 3 terms go down to that. Whatever that is, it's squared. And that side there is that one. And 3 on 2 is there. Now over here, to tidy this up, how do we tidy this bit up at the end?
like the denominator's the same.
We get a common denominator, and I'm tossing up what, say we use 12. And I've done it that way deliberately. So multiplied by 3, multiplied by 3 is 27. And multiplied by 4, and that's 4. Now, that's still
Messy.
a bit. Now, I'll expand this bracket out here, this round one, because I need to do that. Or do I? No, I won't. What's this come out to? Negative 27 plus 4, so it's negative 23. Now, I hope that's right. Because 9 on 4 is 2 1/4 minus a third, so it's pretty close to 2, which is right. You know, it's pretty close to 2. Now, expand that bracket out, the round one. So this is the messy one. 3 times that, the 3 will cancel out into the 12, and I get that. And the turning point, who wants to tell me the turning point?
I don't. Negative 23 over 4.
Who's that? It's that, yep.
Negative 23 over 4.
Yep. Okay, so it's negative 1.5 and negative.
On the test, if we get a question like that, would you want us to turn it into mixed fractions?
Oh, I'd be happy if you did that. If you can do that, I'd be very happy.
Oh, okay.
You want to go
That's
mixed?
great.
That's all right.
Yeah.
Eh?
Yes.
Did I give that impression?
Yes.
A little bit.
I'd be grateful for any small mercies. Is that what you still suggest? No, that's okay. That's all right, isn't it? I hope you do. Oh, in the right way.
Something miraculous.
In the right direction. You see.
No.
Now, right. I had a bit of hassle with my drawings here. The next, underneath the line,
Yes.
there's 1, 2, 3, 4 graphs basically. 5 graphs, really.
Mr.
Or
Charles.
6.
Yeah, I didn't get sheet.
It's a little bit late.
Whatever.
Now, see this one here you're copying down, or some people are. Don't feel you always have to copy the things down. I try to take examples, not that one actually, but from the textbook, so if you need to go back you can. The difficulty with taking stuff off the board, you copy it all down. I remember I did that at first year uni trying to do maths. This guy rushed through the course and he copied everything down. I didn't have a clue what he'd said, but I had all his notes, but I didn't understand it. So sometimes, you know, it's maybe better you just put your stuff down and take note. This is example number 10, and try to follow what's being said so you understand it. Then if you want to go back to it, you can. It's in the textbook somewhere. Okay, now, the first graph, number 1. I've messed it up with too many graphs there. And the graph is simply y equals ax squared. That's the first little graph. Now, how do I find out the a value?
By making X and Y. Oh, by what's it called? Substituting points.
Yeah, you have to know a point on the graph. Now, if you knew a point, and I haven't got any mark there, but if you knew the fact that it went through the point 1, 4, then I could work out what A was. But you have to know a point. So if X is 1, Y is 4, bingo, A must be 4. Equation 2 there, we look at it and say, what's the equation of that line? There's an extra graph there that I needn't be there, and I didn't have time to write it out. There's the second graph was the one that goes through the 4, and you just say, oh, well, the graph of that is y equals ax squared, still the a is there, plus 4, just gone up to 4. So we recognise that, makes life much easier. And then how do you find out the a? Well, you have to find a point. You have to be given a point. So if it goes through the point 4, 6, we can find out what a is. Just sub in there.
So with the plus 4, it's just that the
That's the
y
one.
coordinate on the turning point
Yeah,
is
that's
4.
that one there. If it's go, because it's just gone straight up,
Okay, yeah.
and 4, 6 is here somewhere.
Okay.
The next one is all by itself. What would be the equation of the next one? In the next second little graph? This one.
Which is